Okay, so welcome to the January 2018 paper for physics. I'll try to answer as many questions as possible. But first, let's look at the directions. This paper consists of two sections, A and B. A consists of 3 questions, while B consists of 3 questions. So the candidates must attempt all questions. Basically, the paper has 6 questions. All answers must be written in this answer booklet. Do not write in the margin, so you have to obey the rules. Do not write in the margins. All working must be clearly shown, and that is very important. You may use a silent non-programmable calculator, so make sure you get one. Make sure you have one that you know how to use and you're not just figuring out how to use it on the day of the exam. Mathematical tables are provided, but if you know all of your formulas, you wouldn't need any tables. And if you need to rewrite any answer and there's not enough space to do so on the original page, you must do so, or you must use the extra line pages provided at the back of this booklet. My humble advice, make sure you answer fit in the actual space to give, because a lot of times you kind of get markers upset when you have that extra stuff. My humble opinion, doesn't have to be yours, but kind of fit everything right there. And 10, if you use the extra pages, you must write the question number clearly in the box provided at the top of the extra pages, and where relevant, include the question part beside the answer. There's so much work you got to do if you write on the extra pages. Just make sure your answer fit in the actual question section. So we're gonna start question 1, and question 1 says, a student conducted an experiment on light traveling from glass to air. Figure 1 is a diagram showing light traveling from glass to air. The results of the experiment are recorded in table 1. So that's the figure right there. And usually you will see from air to glass, but this time they went and tried to upset you. And they have the angle of incidence going from glass to air. So it's going from a denser medium to a less dense medium. Now we have the table, and the first question in question 1 asks that we complete that table by calculating the values of sine R and sine I. R stands for refraction, angle of refraction, and I stands for angle of incidence. And that's 5 marks. So you have to fill in 10 spaces, and they're all equal to 5 marks. So this is related to this because you have the arrow here. It's just that you have to find the sine of each of these, and they correspond to the spaces on the side. So once you find the sine of 10, you put it in here, and this column corresponds to this column. You just have to find the sine of each of these angles. So you get your calculator, and I don't have my handy nifty calculator that I usually use with me right now, so I'm gonna put my phone here. And so the first one says find the sine of 10 for the refracted ray. All I'm gonna do is go back to normal and find sine of 10. So sine 10, close bracket, get your number right there. So I got 0.17. I'm just gonna use 1 decimal place because the common factor here is 1 decimal place. We have 3 sig fig for everything except this, which is 2 sig fig. So I'm just gonna go with the 1 decimal place, and I'm gonna put 0.2. Once you do the rest of them, you could do them along with me, you will get the same answers I get. So I'm gonna just fill them in now that I've shown you how to do first one. I don't have to do the rest, so just fill them in, and I'll fill them in up here too. .5, 0.6, and 0.7. That's cool. So we have numbers now. The next question says Using the calculated values in table 1, plot a graph of sine r against sine I on the grid on page 5. And that's for 8 marks. That's a lot of marks. So you see this is for 5, but you fill in 10 spaces. So each of them carry half a point, but 6 doesn't give half a point. So I'm guessing if you get one wrong, they're gonna just take out the mark altogether. I'm guessing, I'm not sure, but anyway. They don't give half marks, just know that. You need to get them all correct because that one was pretty simple. So now what we're gonna do, we're gonna try to graph it. We're not gonna try, but we're gonna graph it. And what I see here is that they said sine r against sine I. So sine r is gonna be our y-axis, and this is gonna be our x. So that's pretty much how physics does it. It's always y against x. And so I'm gonna put the 0 right here. If you count along here, you would notice that you have more than 7 spaces. So it looks like we have at least, if we have 14, we could use double the spaces. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. We have 14 spaces, so we could do double spacing. So we say 0.1. And remember, sine I is going on the x-axis. So our parameters run from 0 to 0.7. So we're pretty good. So 0.1. I was just filling 0.2, 0.3, 0.4, 0.5, 0.6, and 0.7. And if you want, you can put 0.8 right there, but I'm not going to do that. And just put your arrowhead. And for sine, and oh, we need to put our label sine I. So our y-axis, which is vertical, is our sine r, and we're going to put that there, sine r. And we're going to just fill it up accordingly. So sine r runs from 0, approximately 0 to 1. So if you have 10 spaces, more than 10 spaces here, we could go double time. I think this usually has 23 going up. So let's make sure. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. 21. Okay. So we have more than 10. So we can go every 2 spaces here as well. Good. And then we just put it in 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, 1. And so, you know, if you have 0.5 here, this can be 0.5 here. So this is 0.05. So each step is 0. So this would be 0.15. Because you add it. And this would be 0.25. And so up here will be 1.05. Yeah, so we could put that there. Cool. And this is 0.05 here. Because you have 0.1, this couldn't be 0.5 because you already have it here. So if you have points, decimal places, be careful, because a lot of times if you have a scale like this, you forget that this is already here, so this must be 0.05. And the way to do that is just minus the little number from the big number and divide by the number of spaces. So in this case, we're dealing with the 2 spaces here. So you would just say 0.1 minus 0 divided by 2, and you get 0.05. If you want to know what one of the little spaces are, you would say 0.1 minus 0 divided by 10, because you have 10 mini spaces from 0 to 1. Same thing here. That's a whole different lesson. Alright, so I'll just show you how to good measure. So you would do, to find out the spacing between here, so 0.1 minus 0 is always a little number from the big number, divided by, it's only these two spaces we're concerned about right now, divided by 2 to give you 0.05. Want to see if it's really true? Let's do this. So clear, and let's go 0.1 minus 0 equal that divided by 2, 0.05, and there we have it. Okay, and so we could start plotting now. So whenever you have 0.1, you're gonna have 0.2. So you go from here, 0.1, move up to 0.2, put a little dot there, and you circle. When you have 0.3, R is 0.5, so we go here 0.3, and you move up to 0.5. And then when it's 0.5, you go up to 0.8, so you go here 0.5, move up to 0.8, there. And then when you have 0.6 is 0.9, so we go back over here, 0.6, and we're going right up to 0.9, so 0.6 right up to 0.9. And then when you have 0.7, you go up by 1. So 0.7 up to 1.0 right here. And that's how you find your coordinates. Now, you have to find your best fit line using a clear ruler. So it's best if you walk into the examination room with a clear ruler. You need clear rulers, or transparent rulers, or translucent rulers, so that you could measure the distances between your points equidistantly, especially if you have to find the best fit line. Now, my hand is holding the camera, so I'm going to have to put the camera down, and I'm going to draw my best fit line. Just make sure that when you put the ruler between your points, if they're not in a straight line, if they don't all run on the same line, but they seem to form a straight line, in terms of you could pass a straight line through it and find the best fit line, you have to make sure the points to the left of the line are equally spaced away from the points on the right of the line. So you look for the furthest point on the left, furthest point on the right, place it in the center, and voila, you have your best fit line. So hold a second. Okay, so here it is. I made a little boo-boo there, but that's fine. I'm using a pen. Okay, so I have my best fit line, and it looks good to me. So here we go. Now we need to find the gradient. When you go on the next page, it tells you calculate the gradient. And so all you would have to do is to find 2 points on the line. So you will go here. You could elongate the line if you want, but because my hand is occupied, I'm just gonna find a point here. And always make sure you find a large triangle. Use a large triangle to do that. And so your triangle, meaning if I had the axis of my ruler, I would have continued down, going down like this with a straight edge, and I would have continued going across like this to show my triangle. Okay, but my hand is occupied. And so I'm going to number this point as 1 and number this point as 2, the x's. And note while I use different types of points because I don't want to confuse myself. So the coordinates for this point will have 1, so this will be y1 and x1. So whatever y1 is, I go across from y1, I go across and see is 1.05. And then x1, I go from up here to all the way down by the x line, and I see that it's 0.71. Okay? And then this will be my y2 and x2. So my y2 is 0.2 and my x2 looks like it's 0.07. Look like it's here. So 0.07. Now that I've written out my points that I'm going to use, it will be much easier to calculate the gradient. So remember, to calculate the gradient, it's rise over run. So you have delta y over delta x. You can have y1 minus y2 over x1 minus x2. Or you could have y2 minus y1 over x2 minus x1. Okay? Great. So either which way you could calculate it, you can get the same answer, because one of them going to give you two negatives which can cancel out to give you a positive answer, and one going to give you a positive answer, and both the numbers are going to be the same. So you could do anything you want. Just make sure that if you start off with y with a 1 minus and a 2 for one of the coordinates, you must continue with 1 minus 2. You get what I'm saying? In this case, so if you have y1 minus y2, you can't write underneath here x2 minus x1. You're going to get it incorrect. And always remember y is on top of x. You can remember it like this: rise over run. And you know that rise is y and run is x. So if you need to write this down before you do your calculation, do it, because you don't want to forget and you don't want to mix yourself up. Now anyway, let's move on. So we know that our y1 is 1.05. So I put equal 1 point, I'm going to use this one by the way, 1.05, and our y2 is 0.2. I have 0.2 and put in brackets, and our x1 is 0.71 minus 0.07. And we're going to use our calculator again. So we know we're going to press clear, and I have 1.05 and put all, it's going to be in brackets first. 1.05 minus 0.2, close brackets, divided by 0.71 minus 0.07, close brackets, and you get 1.3. So 1.3 is what I got. And so it says to state the name of the physical property represented by the gradient in A3. Once you see sine I over R, or sine R over I, it's refractive index. So refractive index. So how you know that? Just look at what you did. Look at what you did for your gradient. Look at the units you would have gotten. In this case, we didn't get any units, but the relationship between your y and your x is always going to give you what the physical property is that you are looking for. So in this, if you had sine I, you had sine R over I, which is a reciprocal of what you usually do, because we're going from a dense object to a less dense object or medium. So that's why they did it like that. So that's where you have, that's where we say it's the refractive index, okay? And so it says now, explain the term critical angle, okay? What is the critical angle? Do you know? Are you aware of what the critical angle is? Well, here it is. It says, when the angle of refraction is equal to 90 degrees, the angle of incidence is called the critical angle. Then it says, using table 1 or otherwise, state the critical angle for the glass used in A. You just have to read this. When the angle of refraction is equal to 90 degrees, the angle of incidence is equal or called the critical angle. So when the angle of refraction is equal to 90 degrees, the angle of incidence is called the critical angle. And looking at the table, we're going to look for when the angle of refraction is equal to 90. So when it is 90, angle of incidence is 41. So the answer is 41.0 degrees. Okay, and that's just 1 point. So now that we have that, we go over here and I want us to do one more thing for this question. It says, Figure 2 shows light traveling in the core of a fiber optic cable as it reflects off the cladding, and they have the cladding label here. And it says, if the refractive index of the cladding to the core is 1.03, calculate the critical angle in the core. So I'm going to write down my refractive index, which is 1.03. And what we're looking for is the critical angle. So critical angle has a symbol of little c, and that's our x. And to find the critical angle, you would say sine c is equal to 1 over the refractive index. So if you transpose, then c is equal to the inverse of sine and whatever the refractive index is. And we could just go through now and write sine, the inverse of sine, 1 over 1.03, which will give you 76 degrees. How do I know that? Well, again, you use your calculator. And here I have the calculator, and I'm going to clear it. You go to your second function. It's like your normal calculator. So press the second function, and you press your sign, and maybe this might come up in your calculator with sine negative to the -1, but in the phone it comes up as a sin. And I'm just going to type in the fraction. So 1 divided by 1.03, and voila, 76 degrees. So I'm going to write 76 degrees. I hope this helped.